Yes.
I was going to say before you started recording, off-topic question here. I just found out I'm going to have to work over Christmas.
Okay. So today we're going to go over strings and dictionaries. We've worked with strings, but we haven't really done much other than print them out. And a dictionary is a cool thing that you use in Python. It maps very closely. You might have worked with or heard of XML or JSON data format. It looks a lot like that, like a key and a value, key, value, key, value, key, value. And then we're going to do a little bit of work with files. So uh, none of these are going to be in an exercise. I want, if I get through these today early, um, I'm going to give yet more time on those assignments for SQL and a couple of you still owe me a Python problems too, some submission. So we'll work on that. So I'm going to blast through these, and you'll have the notebook as an example of the code. If and when it comes up more in the class. The only time I can think of is like file handling we'll do with this pandas analysis library, because you can open a CSV data file with one line of code and work with it just like you can kind of like Excel. So there is other file handling issues, but and dictionaries, that's the way a lot of data, when you pull it out of an API, it comes out in the form of a dictionary. So if you're going to be working with any sort of web scraping data in Python, it helps to know the structure of a dictionary. And then strings, you mess with that all the time. So I'll get started with that. We'll do notebook 6, which I have already pulled up. And I think I forgot to clear the outputs. If you're following along with your own copy of the notebook, you'll see at the top, in that top markdown block, that there's some files needed. Just you can double click on it and erase that. I missed it. We don't need files for this notebook, so you can get rid of that thing that says required files. And then just like any other time you're in a markdown cell, if you hit Control Enter, it executes the markdown. It makes it pretty again. Okay, so strings are a sequence object, a type of variable, like a list and like a tuple, which we've covered previously, which are just literally a list of things. A tuple, you can't change a tuple, but you can change a list. For really large tuples, operate a little faster than lists, would be the only real difference. And there's a slightly different symbology when you declare them. So a string goes in quotes, where a list was in lists and tuples are in parentheses and brackets. Okay, so Eric Idle, we've declared a string object type called name, and we can use a for loop to go through each character in the string. And this little tiny 2-line for loop will go into name, and one at a time pull out each letter. And the only line of code we have executing in that loop is this print statement. So it will print a letter on a blank line for each one. Each letter will be on its own line. Bam, Eric Idle, and including the space. That's also a character just like any other. So we very often want to find out the length of a string or the length of of a list and use that that number. So remember, the len is a function that will return the length of either a string or a list or a tuple. I think there's a few others that will work with. So this line, all it does is print out the integer length of name, and we can set ch's for character. We can index a string a couple of different ways here. We'll get into the simple most is a single integer in square brackets is the convention for pulling out the sixth character. But remember, Python is 0 based, so it's really the 7th character because it starts with 0. So name sub 0 is capital E in Eric Idle. And that'll print out that one character, which would be the 7th. So 1, 2, 3, 4, 5, 6 should be a lowercase d. And then this last print statement will print out name sub 1, which is actually the second, character. Name sub 1, 2, 6, and 8. So these are just examples of how you can pull a single character out of a string, and that thing there where we have name sub 1 and name sub 2, that subscript character there, that 2 can be a variable. Remember, so sometimes you might be using some other logic to return the location of something inside that string. So you can use a variable inside of here. It doesn't have to be a numeric literal. And we've seen this before. We can concatenate. You don't have to use the concat function like we were using in SQL. Python lets you use a simple, what looks like an arithmetic operation, but it's really just smashing those strings together. Did I run? Yes, 9D ride, yeah. So this just concatenates the two strings with space in between. You do that kind of thing all the time when you're making stuff pretty for printing out. Michael Baldwin. And strings are immutable. Oh yeah, you can't go in and change one of the characters of a string. So you can't, and if you execute this, you get one of these very meaningful Python names. String object does not support item assignment. That means you can't modify the guts of a string using indexing. That's all that means. Simple enough. They are immutable, like a tuple. Okay, so now the starts to get a little more complicated here when we work with string slicing, which in other programming languages like SQL and like Excel, this would be like a substring function where you would pass the string and what part of the string you wanted to a function. But in Python, we use this this general format to work with parts of a string. If we want to pull out something, by position, this lets you do it. So that's the basic syntax. The first number is the starting character of the string that you want to extract or slice. The second number is the ending character, and if you leave it blank, if you leave either the start blank or the end number blank, it defaults to the beginning. For like if you leave the start out, it means start at index 0, and if you leave end out, it means go to the end of the string, and the step variable is optional, as we'll see here in our examples. So here's your rules I just went over. So full name was what? What did we say? Michael Baldwin. We declared that in the previous code cell. So Michael Baldwin, we will print that. And then we will print from character 8 to character 12. Go ahead and get that output there. Bald. Hey, I resemble that remark. Character 8 to character 12, which is really 9 to 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 10, 11, 12. Character 9 to character 8, 9. Oh, it's exclusive. Yeah, I'm sure that's up here in the rules. It's up to, but not including the end. We've seen that before. It's 0 based, and it's exclusive. This 12, it's up to, but not including character 12. So it's actually 8, 9, 10, 11. Just a Pythonism that you just got to kind of get used to. It's something I have to relearn every time I'm messing with it. So this third print statement here will grab, since the beginning is blank, and we've just said blank colon 6, that prints out from the beginning up to, but not including the 6th character, which is actually the 7th character, so it will print the 6th character. So yeah, and that is our MICHAE. So it prints 6 characters. Okay. And then from character 8, begin at character 8 and go, since the second number is omitted, it defaults to the end of the string. So that's where we get this Baldwin printing out down here. It's actually the 9th character. And then you can do negative. The negative sign tells it to go to the end of the string and start counting backwards. So let's test that theory. So we go to the end, and then 1, 2, 3, 4, 5, 6, 7. Yep. B in Baldwin. Go to the end and start counting backwards. And then this last one uses a step value. Start at the beginning. The middle value is empty in this last print here. The middle value is empty, which defaults to the end. But since the optional 3rd character is in here, it means we're going to grab every 3rd letter. So starting at 0, we get the M, skip 1, 2, 3 is H, 1, 2, 3 is L, 1, 2, 3 is A. Yep, that makes sense. So that's your step value. Sometimes you want to go through every other whatever. 2 would be every other character, that sort of thing. So that's how you pull out portions of a string in Python. Again, if you've used other programming languages, that's usually a function. It's not usually so much a subscripting thing, but that's how we do it in Python. Okay, so we can, as we have seen in the Python exercises, you can just use the in operator to see if a short string is in a larger string. And that works really well. And I think we did that in one of the Python exercises where you could do a string of the vowels and consonants and whatnot, and just say if a string is in it. And did by chance darn, Regina did not come in. I wanted to show her using the upper method that you don't you don't have to deal with lowercase and uppercase and whatnot. And just upcase what you're checking. Again, check it against the list of capital letters. Anyway, so yeah, is ham in text? Yes. So let's say is cheese in text? No. So it goes and finds it and returns a Boolean value as to whether or not it was found in that, if it was found in that string. So this next markdown block here, this is one of the things I really wanted to get across and make sure that you guys are starting to get a little more comfortable with the notion of a method and the syntax for it, more than a function. I've mentioned it several times, and this notebook just kind of reiterates the notion of the fact that a string is a type of something. It's a class of well, it's a class, a thing of something, just like floating point numbers are a type of class, and integers are a type of class, and pandas data frames are a type of class, and a list is a class. These different classes of objects have functionality, functions that you can call, and you just need to remember that you use the variable name dot method name. That that this is digit open parent close is very close to like our len function that we used before, but it's not. The syntax and the way it operates is slightly different, because different classes of objects have different methods. There's different things that you want to do with them that you wouldn't really use an is digit for an integer type of object, because by definition an integer is a digit. So that's where we get into this this list here. We have some ways to check a string and return a value. So like I think one of the problems, there was some error checking to make sure that they entered like a zero to stop the loop or something like that. So you can use when you're using the input function, which always returns a string, if you want an easy way to just see if they entered a number, or if they entered a letter, or if they entered alphabetic characters, you can use these Boolean methods on the string. So for example, in this next code block here, we set sale amount equal to quote 4,200 quote. So that Python is going to see those quotes and default to that being a string, just like the input statement always returns a string. When Python sees quotes around something, the first time you declare that variable, it's going to assume that you wanted it to be a string, as opposed to an integer, which if you removed these quotes right here, it would default to being an integer data type. So there you go. So that is a string. Sale amount is a string. And since it's a string, we can use the isDigit method. And all that does is return a Boolean value if the string contains only numeric characters, it'll return true. Otherwise, it returns false. And you can do similar with these other four functions, or I'm sorry, five functions, to check what's in there, depending on what you're doing. It depends on the program, depends on the program logic. So like for this one, for example, yes. So if I add an A in here, it's going to suddenly say no, because it's not just digits. But now if I say, if it is alnum, I believe that's going to come back and say true. Yeah, it's now it is numbers and letters. But if I stick a special character in there, there you go. I believe that's going to return false. Yes. So that these functions go through and do what would be, pretty complicated if then elsing, but you don't have to do it because some programmer put that if then elsing and checking into this method somewhere in the code. And I can't remember off the top of my head, but you can go and see the code for a lot of these libraries. I don't know that you can necessarily see the source code for a string method. That's kind of built into the language. But anyway, trust me, there's all of that complexity, all of that logic has been implemented in this method so that you don't have to. So there's almost always, I find, being an advanced beginner Python programmer, that there's almost always a more elegant way to solve it if you just dig a little and as you learn more. There's a lot of these methods that will save you lines of code, confusing lines of code to do things. So that's what those do. Now the upper and lower, I'm curious if we have a number. What is lower going to return? So it's not lowercase. And is supper? Is supper? Should say no too. No, because it's neither, because it's not alphabetic. So that's the beauty of these built-in string methods. And there's about, I don't know, 20 of them. Let's see if we go to the W3 schools and go to Python strings. Have I mentioned that I love this website? And we go down to string methods. There it is, string methods. This is as useful a list of string methods. I mean, it's in the base documentation for Python, but the documentation is not the smartest in the world. Some of these return it returns true if, returns true if, returns true if. Those return event, but some of them return it'll convert it from lowercase to uppercase, that sort of thing. It doesn't convert the string, it returns a string that is capitalized. So you'd have to assign it to another variable if you ever wanted to use like this capitalized thing. But this is a good list. Look at all these things. I mean, you can't memorize all this stuff. There's ways to split a string and strip certain characters out of a string, change the case, just like Excel or a lot of other languages. There's always really smart functionality once you get into these functions. Okay, so nice little side trip into W3 schools. So that's that one. So there are methods for searching and replacing. Sometimes you want to change something, some part of a string, and they are again pretty self-explanatory. I like going through anytime I run into a new method that I'm not quite sure how it operates. I like looking at it either on W3 Schools or Geeks for Geeks. You'll when you Google something, how do I do whatever? I don't know if they're paying Google or what, but it's a pretty good website. Geeks for Geeks seems to have some good examples. Stack Overflow can be really cryptic. I mean, it's probably the best website for complex issues, and it's definitely interactive. It's a discussion board, but it's not a very good beginner tutorial source. So anyway, see what we got down here on this code cell. So we're going to set our variable mascot to bears, print it out 5 times. We're going to declare another string. Mary had a little lamb. And then we're going to replace lamb with rabbit with sharp teeth, because this is Python, which was named for Monty Python. So that's where our result. Yeah, because it's a string variable, and you start doing things like, the plus sign concatenate strings together, and this one you are just repeating the string 5 times. You're not like, if for some reason, if mascot was a numeric variable, it wouldn't a numeric characters in a string variable, it wouldn't do the math. It just that it operates differently based on the data type. And bears, that's the result of multiplying mascot 5 times. And then this replace method, you see, we've got a string variable dot a method. So what that does is replace the word lamb, or the characters lamb, anywhere that it was in that string. It would replace it with rabbit with sharp teeth. I don't know if you've never seen Monty Python and the Holy Grail, that joke is probably lost on you, but if you have, it's pretty hilarious. So Mary had a little rabbit with sharp teeth, but it doesn't replace it. It just returns this this call to this method, sending these 2 parameters. You send 2 parameters, lamb, which is what you're looking for, and rabbit with sharp teeth is the string that you want to replace it with. It beg your pardon, it returns that modified string, but it doesn't change the string, because strings are immutable. I hope that makes sense. Somebody tell me that makes
So
sense. Go
is
ahead.
that where line 5 comes into play? Like it's just saying test this string, and then is line 6 essentially just printing out a different version of that same string?
Right. Test string. What is in memory is Mary had a little lamb. And we see that here in the assignment statement. And then on code line 7, we print out test string, and you see that it was never modified to equal rabbit with sharp teeth. The variable itself in memory was never, or the contents was never changed. It's just we called a method that returned a modified value. So what I could have done instead of this, let me, this might help. I can say sharp teeth string equals test underscore, if I hit tab, or dot rep tab, and I'm hitting tab is where it's jumping out there. So if I type in rep tab, it knows that I'm looking for a method of the string class that starts with rep. So that autocomplete is pretty cool. So I want to replace lamb with something else. Yeah, just like before. But now we're going to print sharp teeth string. That's not helping because I haven't run it yet, so it's not in the buffer. Okay, so what have I done? I got test string, and there we go. So now I'm setting another variable equal to what this returns, and I'm going to print the new variable. So instead of Mary having a little lamb, Mary had a little rabbit. But that's what it takes to get this, to get the result of this replace call stored somewhere so that it's not just like a temporary thing that gets returned. Leila, is that making more sense? Or is that?
Yes, it is. Thanks.
Sure. Okay. And then, oh yeah, this last method, .find, will return the index of the where this substring begins, where it'll find the first occurrence of HAD in our inside of test string. So if we go to test string, which is Mary had a little lamb, we got 0, 1, 2, 0, 1, 2, 3, 4, 5. Sure enough, H is in the 6th position, which is actually index 5. So that can be handy because you can put the this find and the search string, you can put this inside of a substring slicing format, the slicing syntax. Let's see, I got 5 minutes before I want to break. Let me see if I can't get myself into massive trouble going off script here. So let's say we want to print everything from where we find had to the end of the string. Anything that comes before had, we don't care anymore. We want to print out starting with the word had. So we would print test string. And then we're slicing, right? So we're going to use brackets. So I need a square bracket. And somewhere I'm going to need a right-hand square bracket. So I'm going to go ahead and stick that over here in between. So the first thing in my bracket right now is the starting, that's going to be the starting position of my slice. And then if I do a colon, that means that, and leave it blank, that goes to the end. So this function or this method call where I'm looking inside of test string to get the index of the first occurrence of HAD, that is the same as having this 8 right here. It just returns a number, and you can put anything in there that returns an integer that when it does all of its magic, it comes down and it is an integer. So that should print had a little lamb. This last line of code after the 5 now should print had a little lamb. Unless I goofed it up, in which case it will go and I'll have to troubleshoot it. Let's see, I got one open paren and open paren. I got a bracket and a bracket, and I got a paren and a paren, and it's in quotes, and everything looks good. Let's see. Had a little lamb. Woohoo! So that find method returns an integer where it, of the index, it returns the number of the character where it finds that. But again, it's a method, so you use it like that instead of, like, you might think that you would print, if it was a function, you'd be doing this. Well, I'll do it in a comment. You'd be saying print find inside of test stir and then you'd pass the HAD. So that's how you would do this if Python was doing it as a function call. But that's not quite the way it works as a method. It's a little cleaner, to me. Once you get used to messing with these, and again, this I don't know any better resource than this W3 Schools tutorial. But that's how string slicing and using the search or the find method of the string class works. That makes sense, or can I give you another example before we go on break? Cool. What do you think, Dave?
I'm good.
Okay. You are allowed to say, Don, you're a total nerd and you're having too much fun. Okay. Just got a few more string methods to go over when we come back from break, and then we'll jump into dictionaries. And like I said, I think we'll get, I'm sure we'll get all 3 of these notebooks covered. All right, let's come back at 9:30. All right, back to fun with strings. All right, in this next code block, we set I love programming into the text variable, and then we're going to print the result of calling the upper method and the result of calling the lower method, and then we'll print the original variable to show that nothing is modified when you call those methods. It's just a temporary return value that you can use for whatever you want. And then we're actually going to modify it by changing, by using assignment statement. Text equals text.upper will take what's on the right-hand side of the equal sign, which is going to be uppercasing I love Python programming, and reassign the result to the same variable, to text. And that's perfectly legal. We say, A equals A plus B all the time. And then we will print the new fully uppercased text variable. So let's run that one. Just like we thought, all uppercase letters, all lowercase letters, any non-alphabetic character would just get ignored. We can prove that by sticking an exclamation point at the end. Doesn't know how to upcase a exclamation point. It's as up as it gets. So it ignores any numbers or special characters. But at the end here, this assignment statement changed it. So text is now all capital letters, I love Python programming. Okay, so yeah, methods, and like I said, there are dozens, and they're all very helpful depending on what you're trying to do. To write short, easy to understand, elegant code versus doing only your own if then elsing and saves a whole lot of work. So splitting a string, the split method doesn't return a string. The return value of upper and lower, the upper and lower method is a string. It's a string method and it returns a string. The split method returns a list, which is, a different data type. So we are going to set our text variable, same variable, but we're going to do a reassignment statement here. And we are going to say, your mother was a hamster and your father smelt of elderberries. And again, if you haven't seen Search for the Holy Grail and cook, and the coconuts and all of that, these jokes are meaningless to you. So there you go. Split the string, and the default split function, or no, that's not the right word. The by default split splits on white space, so a space or 2 or 3. It grabs every word basically, and returns a list of the individual words. Now you can and we will in the next code block, you can send it a character to split on if you want to do something besides the default. So we got some easy code here. We got an assignment statement, and then we're gonna make words equal to the text dot split method, which will return a list. So the data type of words will be class list. And then we'll print those words out. And then we will, just for grins, we will upcase your mother was a hamster. All right. So the split method, and we can see here, I'll add a line of code. Print, and type is a function that you pass a variable to, an object. Class list. So, and we can print, we can also use the len function if we want to count the number of words. There's 11 words. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Accurate. Oh, and notice that it's split on white space, so it doesn't really know what to do with punctuation. So it's not, I mean, elderberries period isn't technically a word. It includes the final punctuation. So yeah, you want to be aware of that. So that's how those work. No questions so far? Okay. So now in this next code cell, we are, again, this is a string. It looks like a date. It's not a date data type. It's a string data type because it's in quotes. So we are going to split, and and if you send the split, there's a couple of parameters you can send it, but the first one is a split character. So you can tell it what to split on, and there are some circumstances where that may come in handy with a long, like a text, if you're dealing with a text file with different stuff in it, you may want to split on, I don't know, commas if it's a CSV, and you're not using Automagic, you're doing your own splitting, I guess. Anyway, you can do it. So this split method here will take the numbers. It'll extract the 3 numbers and stick it in a list called date list. And remember, a list can be accessed with an index, just like a string, just like a tuple. So date list 0 is the first thing in the date list object. Date list sub 1 is the second object. Date list sub 2 is the third object. So month, day, and year will pop out just like that. Handy, handy if you're doing that sort of thing. Okay, let's look at this next silliness that my buddy Mike put in here. Dog, dude, cat, dude, pig, dude, goat, dude, all, dude, llama, dude, parrot, dude, not all, dude, llama. All right, so we got a lot of dude stuck in there, and we're going to split that into a list of words on the word dude. So it doesn't have to be just one character. It can be a string that you're splitting on. Then we'll print that out. The join method will concatenate, and that method is common to strings, lists, tuples, where it will it'll stick them together. So we're going to print my list, which will be like dog, cat, and then this line we're going to join that that unduted list to the date string, which we have up here in this previous code cell. And then we're going to show that this last line of code, I'll wait just a second. Let me run this. So there we go. We are joining these lists, the date and the dog, cat, pig result get joined together. And then this one, this last line of code shows that you can, that string literal quote dash quote is a string object. Even though it doesn't have a variable name, it is still a string object in the code. And you can call string methods using that, string object dot method syntax, just like you would with any other string. So that's what this quote dash quote is. That is a string object, and it is calling the string object join method, and it's inserting that one character in with the members of the my list. But I want to see what we got here. I'm pretty sure I want to see the data type. I think that returns a string. Oop, I want to use the type function, not the string function. So that, no, hang on. That's not actually the problem. I believe the problem is before that. We got 1, 2, 3 open parens. I'm missing a closed paren. Because I did an open paren for the type function, but I did not include another closed paren. Bam, there we go. Yeah, the join joins a list and a string and returns a string of all of that together. Could be useful. So I say I'm not going to belabor this with exercises. So here's a programming exercise to end this. A couple of programming exercises to end this string discussion. So this is a program that gets a string from the user using our input. So we want first, middle, last, enter them in first, middle, last, and then displays their initials with periods. So it's going to strip out the first character. So we grab full name using input, and that's going to return a string. And then we're splitting on, we're not sending any parameters. So we're going to split, say I'm going to enter Donald Stanford Walker. So it's going to split Donald Stanford Walker into a list of Donald, Stanford, and Walker as 3 different cells. Okay. And then this double, this starts to get a little more complicated. This double indexing is when you have a list, the first, the first index is which cell in the list. And then if you have a string or a list of lists, the second one is the index for what in that sub item. It gets a little complicated, I know. And that's what we have with name. Name is a list of strings. So the list itself can be indexed. Each string can be indexed with a numeric literal 1, 2, 0 for the position in the list. But then if the list is a list of sequence variables, either string or a list of lists or a list of tuples, each one inside of that can then be indexed. So that's why you have double indexing here. And I know that. So here's an example. I'm not going to expect to apply this anytime soon here. And then we join with a dot and print it out. So we will iterate through name and upcase, add a separator. Anyway, let's just run it. I feel like I'm belaboring things when I'm not going to actually do an application of it. So that shows you how all that works. And then we've got another one. This one requires a file called Gettysburg. I don't know that did I include that? Is that in the classroom? I might have forgot about it. I did. But I've got a data file up here. Look in my data directory. That is the text of the Gettysburg Address, and this this Python navigator, you can pull up. I think we've done it before. You can pull up. It doesn't just work on notebooks. It'll actually look at the guts of a text file. So that's what is in Gettysburg.txt in my data directory. I apologize. I think I saw that and forgot to upload it for you. So that's how that works. This is literally the Gettysburg Address, and you'll see these double dashes are going to kind of goof up our exercise slightly. It wouldn't necessarily need to have that text, but you'll see the result. Gettysburg, where were we? Strings. So we're gonna we're gonna do file handling after dictionaries this morning. So if this is strange, it's totally understood. So what we're doing is opening that data file though, and reading it. Reading it into a variable. We're splitting the sentences by period and space, printing out the number of spaces, and then we're going into each of the sentences and splitting without sending anything, which will get us the words, incrementing word count, and then printing out the count of the words and averaging it um, uh, since we had an accumulator there, we can print out the average. And then print out the actual individual words, and you'll see where some of the words are double dashes because it doesn't know. So let's run that. So yeah, the number of sentences is 10 based on the format, period, space. If that split, if that didn't work, if there was some that were period, space, or a semicolon or whatever, it wouldn't know to do that correctly. And then since we split words on white space, that's why you've got more words than are actually in the Gettysburg Address, because it's counting all these double dashes as words. And average number of words per sentence. So yeah, 277 divided by 10. So anyway, that's just an example of what you might do. Like if you're charged with processing Google words by chance, or social media posts or something like that, you can compare the text of a social media post to a list of other words that your management wants to see if people are using that to describe the product or whatever the case may be. There's just an endless amount of ways to apply this sort of text processing sort of thing. Like I said, we'll work with files a little bit more later this morning. So yeah, like I said, that's an example. You've got it. If you ever need to do this kind of thing, if it's by chance something you're doing with your project, like I can go into a whole lot more detail and help. But there's some examples of splitting strings and finding text within a string. And as always, for a notebook, we say, what do we got? Tenant, file, close, and halt. And I'll put that one away. And I will bring up the next notebook we were going to work with, which is, I believe, dictionaries. Number 7. Yeah. Dictionaries. I've got different versions of all these things. Now, I thought I deleted all the output. Yes. So the one you have, yeah, if you just run it right along with me. So what is a dictionary? It's a lot like what you'd think. It's a lot like a dictionary where you have a key and a value in a English language dictionary or any language dictionary. Your key is the word, the value is the definition, say. So this is kind of like having a primary key column and one of the other columns that depend on that primary key, like employee ID column and your last name. So, but a dictionary is just those two columns, for lack of a better term. Whereas a database table or an Excel worksheet or whatever has multiple columns. But a dictionary is a list of items that you get to not based on their position, like a list or a string. You don't get to the first entry in the dictionary by calling by entry level 0. You need to know the value of the key, and there are methods to run through the dictionary and pull out each key in sequence and whatnot. So that's the basic, but the real use of it, like I said, is there's data out there. The internet is loaded with it that is set up like this key value pair in the form of XML and JSON. So you literally can't process XML and JSON in at least in my limited experience unless you have a little bit of knowledge of what a dictionary is. So, so you use the key to find a specific value. You don't use the index, the position. And the keys have to be these immutable objects, which are like a string or a number. I don't know how you would use a tuple as a key because there's multiple things in a tuple, but you can have a tuple with one value in it. So maybe that's how you would do it. Anyway, and they have to be unique, like a primary key in a database table. You can't have duplicate keys. You can have duplicate values. You can't have duplicate keys. And the values can be any type, and you can mix and match the values. They don't all have to be strings or all integers or anything. You can mix and match them just like you can in a list. And they're it doesn't matter what order they're in anyway. So because Python takes care of all that. Okay, so to declare a dictionary, we use curly braces. So you've got what lists are in square brackets, tuples are in round parentheses, and dictionaries are in curly brackets. Did I get that right? Colton, are you on audio? You do a lot of Python, don't you? Colton? Am I on?
Yeah, I hear
Oh,
you.
hey, Paul, do you work with Python somewhat, don't you?
Not as much as I would like. I'm not like an expert or anything.
Yeah, I'd have to go Google it, but I'm not going to. Yeah, lists and tuples use either square or round brackets. Like I said, I don't remember any of this stuff. There's too many languages running around in my 57-year-old brain. So a dictionary uses curly brackets. That tells Python, be on the lookout. We're going to declare a dictionary. So here's an example of what these things look like. Inside of these curly brackets, you have a key like 1 and a value like John. And then 23, Eric, 38, Graham. Guys, I really need to take this. Just a second. I got nervous and hung up on him instead of answering it. All right. So you'll notice these keys are not in order. That's because it doesn't matter. But they are unique. We have 1, 23, 38, 4, and 50. And by coincidence, John, Eric, Graham, Terry are all members of the Monty Python cast. And you'll notice Terry is repeated here with key value of 4 and key value of 50. And then we also have our next dictionary has a string as the key value. Oh, and the colon in between. So it's key colon value, key comma, key colon value, comma, key colon value. So any little typo in that will confuse it. And they don't have to be on different lines. It's just that's really good for readability. But you'll see on this next where we create the offices dictionary, we're using strings this time instead of integers. John, Eric, and Graham are our key values, and COB 201, Wingo 107, and COB 305. Wingo Hall is actually a hall on UCA if you're not a Go Bears purple wearer. So those are our 2 dictionaries. And just like a list, I got to run it or it won't work. And, there's no print or anything, so it doesn't look like it did anything, but it did, in fact, create those dictionaries. And we can use the length function just like we do. We can print the length of a string. We can print the length of a list. We can print the length of a tuple, and we can print the length of a dictionary. So that will tell us the number of elements in employee, which should be 5. 5. There we go. Okay. So now you guys need to uncomment these one at a time to get them to work. So we use the dictionary, and then we use the square brackets in order to access the individual elements of a dictionary. We use a similar syntax that we do with, like a string, string square bracket 2 gets the third character out of a string. It's the same syntax. It's just that Python knows we're dealing with a dictionary, not a string or a list, and it's going to be looking for key values in here, not index values. That's the key takeaway there. So employee 1 is John. I'll uncomment that. Oh, and sure enough, employee 1 is kind of like a print statement. If you just type the variable. I don't love it, but my buddy Mike sprinkles that syntax within his lessons. I'm too lazy to change it. I'm going to change it this time. Print employee 1. Run that again. John. Okay. And then we can print employee 4, which will be Terry. Okay. Same thing. And then the Eric entry of our office's dictionary is, of course, Wingo 107. And I think I added this one to illustrate its case sensitivity and the error message that you will get if you get the key value wrong. So that's why I think, generally speaking, you don't, as you're coding, you don't want to let like the user enter a key value unless you're going to do the error checking by checking to see if it is a valid key in the dictionary, because it's case sensitive, and your code will crash. Your code will have an error message if you try and access a non-existent element of a dictionary. Bam. Okay. All right. So we can use the in operator just like we do with that string, just like we did previously. So I modified the code just a little bit down here in my code cell, but I'll run this. So we do have an employee 4. So this is like I'm saying about the error checking. So what's a key value that we do not have in employee? 5. Okay. So let's do that. Now it will say not found. It won't crash because this line of code never executes. Actually, I guess that would make more sense. But it never executes, right? Because 5 is not in employee. So the print that would crash because there is no 5 never executes. So that's kind of where it's up to the programmer to error proof and whatnot. Error proof the code. And of course, we have a key value of Eric. So we can use a for loop to loop through a dictionary. And that keeps you from getting an invalid key, and that pulls out the valid keys one by one by one by one, so that you can then work with them. So like for this one, for key, and that's just a word. We could have called that donkey. In fact, let's do that. For donkey in offices, print donkey, and then offices sub donkey. So it doesn't matter what you call your iterating variable in your for loop. It's going to go into offices and pull out the keys, and then you can use each line, each time you go through the for loop, you can use that key value to look up what is in the dictionary. That way you're pulling valid keys out, so you're not going to get an invalid one. You're not going to get an error message. And we're basically doing the same thing down here with the employee table. Okay. Dictionaries are mutable, so you can do an assignment statement using the key value and just adding it, just changing what's associated with that key value. It doesn't it doesn't matter where it's positioned. It doesn't matter. The order doesn't matter. You just got to make sure you use a valid key number in there. So right now, employee 42 is who? Who is employee 42? We don't have an employee 42. We're adding a new one. Okay. Where is the new element position in the dictionary? We don't know. Oh yeah, that's the whole point. We're adding a new employee, Connie. And then we print out the dictionary, and we see the same syntax, which can be really handy as when we declared the dictionary. You see that same syntax when you print it out. So that can be cut and pasted into a new assignment statement, which can be pretty handy. So that's the new employee dictionary with this appended to the end, and like I said, it doesn't matter. So another way to populate a new dictionary is to create it with a blank. This creates an empty dictionary, and then you can add new values with just a simple select statement. So that's just another way. You don't have to create it up front like we did with these assignment statements. You don't have to have all the values up front in one long assignment statement like we did. You can just create it empty and then add them as you go along, like we are. Where to go? There we are. So we are adding a new key value here and assigning that dictionary sub key the value. So that's what that looks like when you're creating a new entry into a dictionary. Okay, and we can change employee 42, which was, be nice if I had more than like 10 seconds of memory. It was Connie, right? Wasn't that the new one? Yes, the new one was Connie. So we're going to change Connie to Zoltan. I want to be big. So they're mutable. So you can add, delete, or modify the contents of the dictionary. And so we're gonna We're going to delete employee 42. We're going to print employee, and then we're going to try and do it again. And I think we get we'll get an error message. Bang. Yep. So the first time you deleted it, it works. It got rid of Zoltan, but then the next time we referenced 42, we had deleted it. So we get this error message. So that's where, as you're writing a program, a lot of work goes into error proofing, way more than we're doing. For those of you that have not worked in coding before, I'm not spending any time, monkey proofing or user proofing this code. And, as an individual analyst, you can get some use out of code that is easy to break because what to put in it that won't break it. So, but it won't be not like something like for the web where you need to be ready for anything that could happen. Okay, so we can have different data types inside of a list. In fact, this is going to be a list of lists or a dictionary of lists. So exams, we're saying that the key value would be the student, right? And so the key would be student. The value would be a list of test scores. So this is where we have that a dictionary of or a list of lists. So kind of like a two-dimensional array, more or less. Okay, so we're going to create this and print it out, and you'll see exactly what I'm talking about. So when we access John dictionary, we've got 4 values. When we access Graham, we've got 4 test values, and so on. So down here in this next code section, we're setting scores equal to exams sub Graham. So scores is going to be a list. Scores will be a list containing 100, 94, 96, and 86. And we'll see that when I run this with this print statement. So now we're going to iterate test over that scores list. So test will equal 100. Where'd it go? Graham. Yeah. Test will equal 100, and then test will equal 94, and then it does the loop again. Test will equal 96, does the loop again, then test will equal 86. So we're going to add all of those numbers together in our accumulator variable, which we've covered before in for loops, using the abbreviated assignment. And then we're going to divide that exam total that we built up by adding 4 scores together and divide it by the length of scores. We don't need a counter to know how many times we went through the for loop because we have the length of the list. So that length variable will return, how many scores there were, how many times we went through the for loop. Okay, kablam. So there you go. Graham's average is 94. Okay, and this still works. I've been using this for, good grief, 2 years now. If you go to this link, it used to be at the time that Dr. Ellis made this notebook, it was $14.74, but I want to say it's almost doubled in price. Talk about your runaway post-COVID inflation. What is it now? Where's my Zoom window's in the way? It's still for sale. Where's the price? $23.40. This doesn't look like a normal Amazon. They usually put the price up there a little closer. Maybe 2340 versus 1474. So I thought it was interesting that the actual thing is still for sale and it still looks the same after 2 or 3 years. So anyway, that's neither here nor there. It's not like we're going to work with the website data. So it's just an interesting aside. So we are going to declare a dictionary with key values description, a key value of part number, a key of color, a key of quantity, one of list price, one of free shipping. Okay, and we get to those again. I got to run it. Don't forget to run it. We get to those entries in the product dictionary by using their key value. So we're going to print the color, the list price, and whether or not it's free shipping. And remember, that's a Boolean value, so it uses the keyword true or false as its value. Black and yellow, 20.94, and true, just like we entered into it, just like you would think. So we can use them in any way necessary. So we're going to say, get the user to put in a quantity, and quantity times the price, and then whether or not it's got free shipping, which ours does. It will add 0. Otherwise, it would have added 9.95. And you could have, a dictionary full of different different values. So anyway, here's what that one does. We're going to sell, say, 3 of these. You ordered 3, totaling $62.82 plus 0 for shipping. So that's how that works. So now we got one more, pretty sure. Yeah, one more programming exercise. This is going to be a program that creates a dictionary containing course numbers and the room they're in. And then we'll create another dictionary that lists the instructors, and then a third dictionary with meeting times. Okay, so then it lets me enter the key value, which is a course number, and it displays the details for it. Okay, so here's our 3 dictionaries that we said we had to create. And then I get an input here, which will be me entering a value, or you entering a value. Inserting a blank line, print statement with nothing, just gives us a blank line. And here's a little bit of error checking. If course not in rooms, then rather than have an error message, we avoid this print statement. But if it does exist, if they entered a valid course number that's in this rooms dictionary, then we print this cool information down here. All right, so if I use the right letters, 2, 3, 4, 3. There. If I run it again and put in something invalid like Comp 101, that's not a valid course number. So that works out. And then down here's an example of other dictionary methods. But again, I would, if this is valuable to you at all, I would go through the W3 schools and grab them all and go through that tutorial. It explains the usage of each and every method and gives you an example, gives you the syntax, sample code, works like a champ. For key value and office.items, print the key and the value. And then the delete method lets you get rid of a key value pair by accessing the dictionary by the key there. So we can get rid of the Eric entry in offices by just doing that. So he's no longer in there. There you go. So that's dictionaries. When you have a known key value pair, which happens all the time dealing with the internet, the dictionary is the way you'll mess with that. In fact, like, yeah, HTML, there's just a whole lot of stuff out there that works in key value pairs. Any questions on that? Like I said, I don't really plan on assigning anything practical application wise when it comes to dictionaries. All right. Let's come back at 10:30 and we'll wrap things up. Break till 10:30. Okay, we'll knock out one more notebook and be done for the day. And that is dealing with files. This is something you do a lot when you're dealing with really any kind of data or even a lot of processing. But there are different kinds of files. This is just going to focus on just a good old-fashioned text file. So let me share my screen without further ado. Okay, so yeah, there's 4 text files that are out there in my data directory, which is at the same level as this notebook directory. So I just wanted to go over an example of what monkeying around with a file does. So there's 2 kinds of access. You can go directly to a line in a file. My experience is mostly with sequential access, where you're just basically reading each line by line and processing. Sometimes you ignore the line depending on what you're doing. Okay, so we're going to do text files, but next year we're going to work with CSV files in pandas, which makes things a little bit easier. So for all file handling, though, there's 3 basic steps. You open the file, so you got to tell the program that there is this file out on the hard drive that you want to work with, and create an object that is the file, or at least a pointer to the file. And then you process the file. You do what you're going to do with that file. All depends on what the task at hand is. And then you close the file. I helped a student write an email automating program that was pretty cool. You read a CSV file and or actually an Excel file, and used each row and the columns inside there to send an automated email to folks at work. It was pretty fun. But these are the same yet. And closing the file, you want to do that. It can, if you don't close the file that you've opened, you're kind of in charge. When you're writing your own computer program, things like Word and whatnot will have logic written into them to keep you from corrupting the file. But when you start messing with files with a programming language, you have to be that person. you are the programmer. So make sure you have a close command for any file that you open off of the hard drive. I haven't had a problem where I've corrupted a file, but it's always something that could happen. Okay, So the way we tell Python, I want to work with a file is by assigning a file open function to a variable name, a variable or to an object, and then that becomes a file object. So we give we want a meaningful variable name. So if it's your input file, having something to do with input files is always a good idea. The file name over here is going to be the actual file name out on the hard drive. This is just the template. And then the mode is one of three things. You want to open it for read, which is how I tend to operate. Opening a file, an input file. I don't like messing with the original file. I always save, like in Excel. I never mess with the original data tab. I leave that data raw. When I'm messing with an input file with Python, I generally open that for read, and I'll do whatever I got to do to another file. I just hate changing an existing file, but it's absolutely a technique that you need for certain operations. So you can open it for read, you can open it for write, and when you open and put W in the mode here, it erases, if there was one of that type or that file name, it erases it and starts you out with a blank slate to write to. You can't read from it because it's an output file. It's been opened for writing. And append, you're open for writing, but it doesn't erase the data. If you open for append, you're by default you are appending lines to the end of the file. Okay, so you'll see in my notebook here that I use this R for raw in front of my file names, so that it doesn't get goofed up. Slash is a special character for Python. So I always put this R in front so it won't interpret the Python as an escape character. And you'll see that in the notebook that I provided. Okay, so like I said, this one, I'm in my notebook directory. So I will go and see what I got to go. I'm in my notebooks directory. This next code cell is going to open a text file. And since there's no path, it's going to open it in the current directory. That's the way it operates. So let's see if I have a Grail down here. If I do, I'm going to delete it so we can start from scratch. Those are all notebooks. Now I got Grail.txt. So using the file navigator with Anaconda here, I can click on that and go back to the top, and I got a garbage can icon. I want to permanently delete Grail.txt. So it does not exist on my hard drive. These are in alphabetical order. No Grail.txt anymore. So if I open or if I run this code cell, I'm going to create a file called Grail.txt for write, because the mode is W, and then I'm going to write these lines to the output file. So why do I need this /n at the end?
That's like a line or something, right? I forget.
Correct. By default, that write statement will not advance to the next line. There are some programming languages where it's a different command. I want to say in Pascal, I would say write ln, write line. WRITELN. And that command added a new line character. But if we didn't have these /ns, all of this Sir Robin 6527.189 King Arthur, all of that would be on the same line. But if you include a /n, it's the escape character, and it turns that into a carriage return line feed pair to go to the next line, so that Sir Robin and that number and King Arthur and that number will go on their own individual line. Okay, so let's write this. Open it, and then yeah, there's my close. Okay. All right. So we're going to open that, and then we're going yeah, we have to write string values out to a text file. So make sure if you're writing out to a text file, make sure that you convert anything that's not a string to a string. So we're gonna send another line out there to it. So right now, it doesn't look like we're doing anything, right? We opened this file, we wrote some stuff, but you can't see anything. But there is this grail.txt now. This does exist. It says it was created seconds ago, but there's no bytes in it right now. I made the mistake of clicking on one while I had it open and was writing to it. Right now, the file exists on the hard drive. You've told the operating system I want a file, but you haven't actually everything that we're doing. This output file.write is kind of doing it in memory. It's writing to that object, that output underscore file object, but it's not actually sticking them out in that file on the hard drive until you close it. I've done a few experiments, and that seems to be the way it operates without having a master's degree in Python. So we wrote that out. Now if I close that file, we're done. Now we can go look at it with the Explorer window, and it's got 50 bytes in it, which is just those few little lines that we can look at it. And there we are. There's our Sir Robin and our number, and our King Arthur and our number, and that integer number that we converted to a string and wrote out all on their own line in grail.txt. So that's just really basic file stuff. But we can also, I don't have it open. Yeah, we can also open that same file, grail.txt, for append, and we'll have what's in there, and we can append another line that says King Arthur. We can append another line that says Sir Gawain, and another modification of sale price that we are converting to string. That's in there. Remember, sell price was that 8.24? Yep, 8.24. So we got to convert it, do some math on it, and convert it to string. And we're adding the new line character to every line. Add some more lines. So here we're converting the number 4 to a string. And then we are closing grail.txt again. So we opened it for append, added some stuff, made sure it was all string values, wrote it out to the file, and then we closed it again. So let's run that code cell. Yes, I already did. And we go back to the Explorer window, and now grail.txt is 84 bytes, which makes sense because we added some stuff, went from 50 to 84. And we look, and we've got our additional Arthur and Gawain and those numeric lines that we added. Easy peasy. Okay, so we can also, I think the cooler thing is that we can read data from a file and use it for our purposes. So we're going to read, we're going to open, and we're going to use a meaningful name in file, but we're going to open that very same grail.txt that we opened and closed a couple of times, but we're going to open it for read. So we can't write anything to that file, but we can read lines. And if you use this read line, okay, so in file is an object of the class file, right? In fact, I need to confirm that at the end of this. Before I close it, I want to print the type just to confirm what it tells me of in file, and then close it. And then we print. Okay, so when you use the read line method of the file class, it automatically reads a line and goes to the next line. It automatically increments. So this read line will execute in order, and it will advance to the next line, so that line 1 and line 2 and line 3 will be different. They'll be the first 3 lines of that file. And then we close it, and then we'll print line 1, 2, and 3 to prove it. Text IO wrapper, class IO text IO wrapper. Okay, so in English, it's a file. It's of class file type. So it's going to have its own methods. And when you go out to the documentation or whatever, you just look up file handling methods, and there's stuff out there that can use for processing files. Okay, so we printed this line 1, line 2, and line 3, which proves that it is each read line goes to the next line, so that the next read line will be, the one after that. While the blank lines, read line advances to the next line, but each line has a new line code at the end. So the print automatically adds a new line. So we're kind of doing double duty there. We're getting the new line from the print command and the actual new line in the data file. So we can use a method called rstrip to strip out that new line, and it will pull that off of the data before we print it. So we'll add those 3 lines up here, which right strips this from the right hand side of this. Line 1 is a string data type. It's one of our string methods. So we'll run that, and now we don't have the additional blank lines. So just something to consider if you're ever doing those sort of operations. Okay, so reading numeric data. Now I've got numbers.txt that I gave you guys is, right now I'm in notebooks. So I'm going to go up 1 and then back down into data, and I've got numbers.txt. I got a whole bunch of garbage actually, but numbers.txt right here. And that shows you what we got: 16, 2.45, and so on and so on. So there's 7 numbers in numbers.txt. Okay. And because it's a text file, not a notebook, there is no close and halt. You can just delete, you can just X out of that tab. Okay, but this in file open, the R means, interpret these slashes as exactly what they are, not as escape characters like a new line character and that sort of stuff. So we're going to open ... means go up 1, and then we're going to open the data directory numbers.txt, and we're going to open it for read. Then we're going to read the first 3 lines and convert them to float. Now, if they were string variables, you know, that would goof up. So that again, this is not bug proof or user proof or whatever code. It's not bulletproof by any stretch at all. It's absolutely depending on numbers, it being in that numbers.txt file. Okay, so we're going to set num1, 2, and 3 equal to the first 3 lines in numbers.txt. Add them all together into total, print them individually, print the total, and then close that same file object. And of course, we get the same result as I got the last time I ran it. So that's opening a file, reading some data, processing the data, closing the file, just like we said up in the beginning. But just like any other thing, looping through the file is how you normally do this kind of stuff. Start with line 1 and down to the bottom. So there's 2 ways to do that. There's just like any other looping exercise, there's basically 2 loops. There's a conditional loop, which you loop until some condition is met, like no more records in the file. Or there's the for loop, which does things a prescribed amount of times, like for every line in the code, for every line in the input file. So you can do both, and there's examples of both while we have right here for your Python library expertise. So here we go. We're opening up numbers.txt again, and we opened it for read before, so we didn't do anything to it. So we're going to open in file again, numbers.txt, and we need a priming read for the loop. You got to get something into the loop variable so that the while loop will execute at least the first time. So we read the first line of the input file, make sure that it's not a blank file. So while line does not equal nothing, now we will go into this this while loop, and we'll convert what we read to float, print it out, and then read the next line. Remember, inside of a while loop, you are responsible as the programmer for setting a condition where the loop will terminate. Otherwise, it'll sit there and asterisk on you forever until you hit the stop sign or the Control C. So this here inside of the while loop will read each line, and then it'll do it again as long as the previous read didn't hit the bottom of the file, didn't hit the the end of file character. It will do the while loop again, and so this is basically, in English, do while more records is kind of what they used to say, I believe, in COBOL. So yeah, that runs through the every line in the numbers file, and then of course at the end we always close out the file. Okay, so that just prints out every line in the using a while loop. Okay, and then I also have a sample text file for another example in the data directory, sample text, which is just a few lines and then a couple of blank lines and then a couple of lines, which gives an example of what happens in a while loop when you hit a blank line. It stops. So all this does is open sample text, do a priming read, strip out the new line character so that it won't show up when we print, and then we drop into the while loop, where we do basically the same thing. We're just reading it and stripping out the we're just printing each record, right? Printing each line. But you'll notice once we get to these blank lines, we never get to Mary Had a Little Lamb, Woo Pig Suey, because there are blank lines in between. And that's, null values will, potentially mess you up in any of these tools in Excel or Python. So just something to be aware of. And that's something you could have potentially fixed in the data wrangling phase of analysis to make sure that there aren't any lines. But the for loop will continue on. We'll see that here in just a second. And it's easier to use because it doesn't require a priming read. If you're going to go through every line, it's the way to go. It automatically reads the next line each time you go through the for loop, and it stops at the end of the file. So this one, notice how we get more than with the while loop. Why is that? Because it doesn't stop until the end of file is reached. It's not doing a check for the blank blank like this line of code. It's not checking to see if we read nothing, a carriage return line be pair. It just goes through every line regardless of what's being read. And we didn't strip. I did not strip the new line characters. Why you get all these extra spaces, because I didn't do anything about the extra new line. But that's why you get every line using a for loop. And the real easy way to just like open a file and show it is to open it for read, and then you can say print, and then there's the file.read method. And then close it, and it just automatically does everything in those 3 lines of code. But I'm gonna look up what's the difference between read and read line. There's 2 methods we're using here, read and read line. I can't remember the difference off the top of my head. So there you go. Here's another programming exercise. We're going to read integers in and count them, total them, average them of all the numbers. So there's no, and I say make sure the data file and the code are in the same folder. That is also not correct. Make sure the data file, let me change that for next time. Make sure the data file is in the data folder. I apologize. We'll enter bam. Okay. So our integers.txt is up in my data directory, just like always. So we're going to do, just like we did in for looping before, we're going to have a counter variable and an accumulator variable. And we'll go through every line in the file and convert, because remember it reads it in as a string, so we need to convert it. We're going to convert it to integer with this int function, and we're going to add that value to total. We're going to accumulate the different values into total, and then we have a counter variable for each time we've gone through the loop, and then we do the math to average them out and print out the result and close our file. Okay. So here's another short program that shows some processing, and we'll go back to using the while loop. So up to this point, we have been practicing with single data points on its own line in a text file. But generally, yeah, you're going to be working with fields like a CSV file. So, working with text is flat text files, a little bit old school, but these are good examples of that. But we got to know what the data looks like. We have to know the format of the data. Okay, so you can have there's wide data and long data, they call it. Wide is where you have your data set in columns, and then each row is a set of data. But you can have it in what's called long format, where each column is on its own row. So you've got, like, if you had like 10 columns, you'd have 10 rows with a value on each row, and then you'd have another set of 10 values, and then another set of 10 values, all on their own row in a text file. So we'll take a look at fast food in using the Jupyter Explorer, and that is in the data. Fast food, A, B, C, D, E, F. There it is. Fast food, not fast food 2. That's the one I use for output. But fast food, you see here, we've got 4 elements, each on their own, or 4 lines that equals a record, basically. So that's how that data is arranged, just as an example. So we're going to open that up and use the while loop to print out what are really changing it from long format to wide format. So once we print it out, each line looks more like a record, like you're used to. That's all this code does. And of course, closes the file out. Okay. This next one actually imports a library called OS, which is short for operating system, that lets you do things that are out there pulling information and working with the operating system, like getting the current date is often an operating system function. So anyway, we're going to import that. We got a Boolean assignment here. We're going to set found to false. We're going to ask the user for the name of an item in the fast food. It's going to be in the fast food file, and we're going to enter a new price. So we're opening fast food for read, and then we're going to open a file in my temp directory, which is just a temporary working directory up here next to TMP right there. That's where I use that naming convention, and it will create that directory for you too. I say that if you don't have a TMP directory, I'm curious if this crashes on you guys, if you have to go create that file, that folder with the operating system. Somebody let me know if this bombs on you. So yeah, we're going to create a temp file that we're going to write the new price out to, and then basically rename the file and be done. So here we are doing our requisite data conversion over to float. And we're yeah, if they find the file, if they find the item, great. Otherwise, we write it out to it. So we change it if it exists, we write a new one if it doesn't. And then we close the stuff. All right. So in order to delete a file, here's what I was trying to get to. This OS dot and then a function or a command is how you do commands that are not in the basic Python syntax. And it seems like we've done this with another library before, and I'm having trouble remembering what it was. But this OS dot, that's how you delete a file out on the hard drive. You have to work with the operating system because the operating system does all the, the file management for you. So that's where this command is. It's in the OS library that we imported up here. Import OS. And that remove function will get rid of my fast food 2. I don't like messing with my original file. So I'm deleting fast food 2 from the last time I ran this code, and I'm renaming temp to fast food 2 so that I maintain my original input file, just because that's the way I work. Okay. And then if it was found, we tell them it was updated. Otherwise, if they added a bad one, we never do any of this stuff. So, all right. So let's run that. And we got to go look at our hot space dog lowercase or French space fries is $14.95. So let's run that and make French and the name of an item, French fries, $500. Now, ideally, you would do this logic where you wouldn't if they typed in an item that didn't exist, you tell them, hey, that doesn't exist. You wouldn't go through all this. So the logic of this is, but it's really more about file handling examples than it is about the actual logic. So yeah, I don't modify fast food, but if we go to back up to our data directory, fast food 2 should have our $500 French fries in it. Boom, there it is. There you go. Okay. And if you want to challenge yourself, here's a programming exercise at the end. Holler if you want help with that one. Okay, so that's file manipulation. We'll get into similar operations with CSV files and pandas after we get done with Power BI. Okay, so there are some assignments out there that have blanks in them, and you know how I feel about that. Jim, are you on audio?
I am, sir.
Please,
Yes.
yeah, fight that character flaw to get it all perfect, and give me some feedback here, guys. I'm staring at a. Go
I
ahead.
am working on it. I had an issue with the files running, so I couldn't get. I couldn't see if my code actually worked when I hit run on the Python sheets. It fixed it. So
Okay.
now I can actually see what they say.
Okay. But
All
give me some idea of what is going on.
Yes.
Not just you, Jim. You're in good company. But
Yep.
there's a lot of those assignments are still blank for those SQL assignments, and I've got a couple folks that owe me still Python 2. So give me some idea that you're not just literally staring at a blinking cursor, because we should have gotten together if that's the case. And so I'll give you back this last hour to clean that sort of stuff up.
Yay.
We are we're done. If you, I mean, I'm taking downtime, but I can certainly get together for a little while. If you're working over the holidays, I'm not starting Monday. I'm not working any hours. But if you need me, you got my cell. Probably best to text me because I may not necessarily check email. But if you're at work and trying to get something rocking and it's not helping you, I certainly don't mind coming online for a little while and working with you. Otherwise, we will reconvene at 8:30 January 4th, Tuesday morning. Make sure Power BI works on your workstation. Otherwise, you won't be able to follow along. And we're going to have Mr. Daniel Gutierrez from a company called Expansion come in and we're going to have a 4-day learn a little, do a little, learn a little, do a little worksheet, kind of like Mary Kate put on for us for Excel. But using Power BI, which is the next level piece of software to do the kind of stuff you do in Excel, only better, I think, for publishing the results of your analysis to an audience. So any any questions on what I covered today?
No, but I do have a question for one of the SQL assignments.
Sure.
I'm trying to, let me find it. So number 5 on Northwood's single group function problems.
Okay, number 5.
So you want a field that changes the name of the business building to CSC.
Let me look. Hang on just a sec. I got to go find the assignment to remember what in the heck I'm getting there. Click by click. And that was, what's the name of the assignment?
Northwood single group function problems.
Northwood single group function problems. Got it. And then number 5. Okay. What's the question?
You want a new column called new location, a field that changes the name of the business building. So anything that's BUS to CSC while keeping the other buildings the same name. So I've got all my tables joined and I'm having trouble producing that new column, new location.
Okay. I thought I had those in a. I thought I had those. Here we go. Let me pull that up real quick. And make sure this. I didn't goof it up since the last time I messed with it. Yeah. Okay. Yeah, there's a replace function that we didn't. I don't think I covered. Let me put that into chat. It's a like a conditional replace function. Chat. Can you paste that into Workbench? And
Oh, yeah, let me pull up.
yeah, so what that does is it calls the replace function, and where it's almost like a case statement, almost where building code equals business, it makes it CSC. That was a bit of a curve.
This is a where clause.
It's in the select statement. I just put it in the chat.
I'm not seeing anything in the chat.
We're on Zoom, right?
Yes. The only thing I see in chat is Hunter said, I think couples are parentheses.
Oh, well, you know what, Paul? You know what, Paul?
Didn't hit enter.
You can paste into the chat window, but if you don't hit enter,
Okay. I see.
so that replace function for everybody else that's working on this looks at the building code column for every row, because it's in the select statement. So it's gonna operate for every row that gets returned. It's gonna look at the building code and replace the return value. If it's BUS business, it's gonna replace it and make it CSC.
Cool.
And that is
I've
only
never
something. Yeah, I never covered that. That's something that one of those bajillion SQL functions. I don't believe I ever covered that, did I?
I don't think so. I've never seen it, so I
Well,
was
cool.
how to do it.
How cool. Something new for you.
Yeah.
That's a challenge. All right. Anybody else got anything in particular like that we can look up? All right. I'll give you back the last hour of the day. Please, 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 please. Post something. I'm giving you back an hour. So that gives you an hour to, even if it's a blank file that says, Don, I'm having trouble with this. I want to get together one-on-one. Upload something to all of your assignments in the next hour, please. Even if you've made no progress, because honestly, guys, it's just the way I'm wired. If I'm not getting questions and I'm not seeing anything turned in, it affects me viscerally. It affects me physically. I just start getting nervous and wondering what's going on. So upload something to every assignment and go into the new year without me having, a paranoid OCD attack. Okay.
So then is the deadline on these not midnight tomorrow? You want it all done in the next hour?
Well, yeah, I thought I had put today. I mean, we had 4 hours on Thursday. I think folks were taking a crack at pretty much everything. I got very few questions. So hopefully you were taking a crack. Hopefully you're not just going back to work. That's what has me really worried, is that you guys are letting work suck you back in, which violates the agreement that we've made with all of your employers. But yeah, if you could, okay, Paul, if you will work on these with that additional time, fine. End of day tomorrow is fine. It is just really affecting me to have so many blank assignments. And that's all I will say about that. You guys know how to get a hold of me if you need me. And I will see everybody in the new year, 2022. Man, that sounds so futuristic. Leela party. Okay. All right, guys. Merry Christmas, Happy New Year, and I'll see you next year if I don't see you before. Oh, Jasmine, before you leave, Jasmine, you there? Jasmine, are you there?